There was a time, not too long ago, when the vastness of the universe was felt only through the stirring of the human imagination. Without the aid of telescopes or modern tools, the ancient peoples looked up, searching the sky, wondering what was beyond the twinkling stars that stretched into infinity. Under that endless canopy, they gazed in awe, but also in profound uncertainty, unable to grasp the scale or the depth of what they were witnessing. It was as though the sky was both a map and a mystery, a compass guiding them through their existence, but leaving them with more questions than answers. Now, with every advancement in technology, we peer deeper and further into the vast expanse. We have come to know the names of stars, to understand the paths of galaxies, and to measure the light that journeys across time and space. Yet, in all this knowledge, the same profound question still lingers. What is the true nature of the cosmos? Take a moment to imagine the view from a dark, quiet hill in the middle of nowhere. The air is still, the world quiet, except for the soft sounds of the night. Above, the stars shine with a brilliant clarity. The night sky stretches, an unbroken blanket of light, so vast that it seems to swallow everything in its path. You are tiny, insignificant, and yet, in that smallness, there is something awe-inspiring, something deeper. It's impossible not to wonder, how far does this sky stretch? What if this sky, this vast expanse, was not just vast in the way we think of large things, like mountains or oceans or endless deserts, but in a way that defies our understanding of space itself? When we look up at the stars, we see something that's both immense and, in a way, strangely familiar. The observable universe, a stretch of space we can see, measure, and understand, reaches out 13.8 billion light-years in every direction. But can we even begin to fathom what that means? A light-year, the distance light travels in 1 year, is about 5.88 trillion miles. Now imagine that, not once, not twice, but 13.8 billion times. Can you see it? Or are you starting to feel small as the universe continues to stretch, like the fabric of a great tapestry? The stars, the galaxies, the nebulae, each a swirling, glowing mass of dust, gas, and light, form a cosmic web, connecting one galaxy to the next. There are more than 100 billion galaxies in the observable universe, each of those containing billions of stars. Some stars are born, live, and die in the blink of an eye compared to the vast stretches of time, while others have existed for billions of years. The enormity of it all is both beautiful and terrifying. But perhaps the most mysterious thing about all of this is the universe's very nature. We've been taught that the universe is expanding, that everything in it is moving away from everything else, as if we are watching a balloon inflating, its contents stretching further and further apart. The idea, once an abstract concept, was made real by the brilliant observations of Edwin Hubble, who in the 1920s confirmed that galaxies were indeed moving away from us at speeds proportional to their distance. The universe, it seemed, was stretching at a rate that we could measure, and the farther away a galaxy was, the faster it was receding. And so, the story we've been told for decades is clear. The universe began as a singularity, an infinitesimally small, infinitely dense point, before exploding outward in what we call the Big Bang. From that moment of cosmic birth, everything began to expand. Stars were formed, galaxies formed. The entire universe itself began its continuous expansion, pushing space itself apart. Yet, despite our understanding of these processes, a question remains: is the universe truly infinite? Or is it possible that it's just a great cosmic loop, continually stretching and collapsing in a never-ending cycle? Some might dismiss this as a strange thought, an outlandish theory with little to no evidence. But as we dig deeper, the universe begins to show us some strange, subtle hints that suggest there may be more at play than we realize. Perhaps the universe isn't endlessly expanding into a void. Perhaps it's expanding away from something, or toward something. What if, in the grand scale of time, this expansion isn't the beginning of an eternal stretch? What if the universe is simply in one phase of a much grander cycle? A cycle of creation, destruction, and rebirth. What if we are stuck in an infinite loop where time itself isn't a straight path, but a circle? This question isn't new. It's been whispered by cosmologists and philosophers for centuries. The ancient Greeks considered the idea of an eternal universe, forever looping through cycles of birth and death. And though science has made great strides in understanding the cosmos, we are still left with the possibility that what we know may only be a fraction of the truth. So, we stand on the precipice of a great mystery. The observable universe, as vast as it is, may not even be the end of the story. The galaxies, the stars, the black holes, all of it could be part of a much larger, much stranger truth. What we've been told, what we've learned, may only be the surface of something far deeper. And as we look up into the infinite night sky, we must ask ourselves, are we truly seeing the universe as it is? Or are we merely glimpsing a moment in an eternal cycle that we are still too small to comprehend? It was once unimaginable, a concept so profound, so mind-bending, that it seemed like the kind of story best left to ancient myths and legends. But then, in the early 20th century, a breakthrough came from a man who would forever change the way we view the universe: Edwin Hubble. With the development of more powerful telescopes, Hubble discovered that the universe was not static, as once believed, but was expanding. Galaxies, it seemed, were not only moving away from us, but the further they were, the faster they receded. This discovery sent ripples through the scientific community, challenging the long-standing idea that the universe had always existed in a steady, unchanging state. The implications were staggering. If the universe was expanding, that meant it had a starting point, a moment of origin. And if it had a beginning, then perhaps everything. Stars, planets, galaxies, and even time itself was born in a single, cataclysmic event. The concept was as simple as it was mind-blowing: the Big Bang, a moment of intense energy, where all the matter and energy of the universe were compressed into an infinitely dense point, before exploding outward in a rush of creation. This theory, though radical at the time, began to make sense of the evidence that had been accumulating over decades. But there was still a key question that remained unanswered. How far does this expansion go? As scientists delved deeper, they discovered something even more perplexing. Not only was the universe expanding, but it was accelerating. If this quiet journey into the unknown speaks to you, subscribe and drift deeper with us. The rate of expansion was speeding up, driven by a mysterious force scientists would come to call dark energy. This discovery opened a new chapter in the story of the cosmos, one that was far stranger than anyone could have imagined. Dark energy is the name given to the force that seems to be driving the universe apart at an accelerating rate. It's invisible, undetectable by traditional means, and accounts for around 68% of the universe's total energy content. But despite its vast influence, it remains a complete mystery. The more we learn about dark energy, the more we realize how little we truly know. And that's where the mystery deepens. For centuries, we've been taught that the universe was expanding outward, like an ever-inflating balloon. But what if this is only part of the story? What if the universe is expanding, but not into nothingness? What if it's expanding away from something, or from some event, a great cosmic event that we've yet to fully understand? Could the universe be part of a much larger cycle? A rhythm of expansion and contraction, creation and destruction? This idea is not as far-fetched as it might seem. In fact, it echoes some of the earliest models of the universe, which saw the cosmos as a cyclic entity. Instead of an infinite stretch outward, perhaps the universe is simply in the phase of expansion. One moment in a much larger, ongoing process of rebirth. Could this endless stretch of space be part of a grand, cyclical loop of cosmic creation, where each Big Bang is not the beginning, but merely the latest chapter in an eternal rhythm? As we stand at the edge of our understanding, we are left with a tantalizing thought. The universe's expansion, the strange acceleration, and the role of dark energy. Could they all be part of a much larger, unseen process? What if we are trapped in a loop of creation and collapse, constantly expanding, only to contract again into another Big Bang? And what if, as we continue to observe, we are simply seeing the latest phase of a much older, far more complex pattern? We may never know the full extent of the universe's true nature, but one thing is certain: the story of the cosmos is far more intricate, mysterious, and awe-inspiring than we could have ever imagined. And as we continue to peer into the depths of space, we might just be scratching the surface of a cosmic truth that has existed for eons, before the stars burned brightly in the night sky, before the galaxies spun their spiral dance, and long before the discovery of the expanding universe. Ancient minds gazed into the heavens and saw something very different from what we see today. They didn't envision a universe that began with a single burst of creation, nor did they imagine an infinite expanse that simply stretched on forever. To them, the universe wasn't just a place. It was an organism, living, breathing, cycling through endless phases of creation and destruction. In the ancient cultures of Vedic India, Sumer, and Egypt, the universe was seen as a being with a pulse, a rhythm that governed all of existence. It was alive, yet it was also in a constant state of becoming and unbecoming, as if it were breathing in and out, forever shaping and reshaping itself. These cultures did not view time as a linear progression. There was no beginning and no end, only an eternal cycle. In the Vedic cosmology, the universe was thought to undergo a series of cycles known as yugas, ages or epochs that followed a divine rhythm. The universe would be born, live, decay, and then be reborn. It was a constant cycle of creation and destruction, with no beginning or end, just an endless dance of birth and rebirth. This concept of cosmic time was not measured by centuries or millennia, but by kalpas, vast, unthinkable stretches of time. At the end of each cycle, the universe would be dissolved, only to be reborn in another cycle. Across the ancient world, this idea of cyclical time was mirrored in the Sumerian and Egyptian traditions. The Sumerians spoke of the great wheel of time, a wheel that turned and brought about the constant reshaping of the cosmos. In Egypt, the concept of Ma'at, the divine order of the universe, suggested that the universe existed in a delicate balance, forever maintaining a cycle of creation and destruction, an endless rhythm of life, death, and rebirth. The Egyptian myth of Osiris, who was killed, dismembered, and then reborn, echoed the idea that the universe itself was a reflection of this eternal cycle of life and death. But what if the ancients were right? What if the universe is not simply expanding into the unknown, but pulsing with an ancient rhythm, breathing in and out like a great cosmic heart? Consider, for a moment, the possibility that the universe itself does not merely stretch outward like a balloon slowly inflating, but follows a deeper, more intricate pattern of cyclical renewal. The stars, the galaxies, the black holes, they are not just the products of an ever-expanding universe. Instead, they could be part of a grand process that follows the same rhythm of death and rebirth that ancient civilizations once understood. Imagine the universe as a giant organism, its pulse echoing through time. At the end of each cycle, everything collapses, only to be reborn once again in a new form. This process would not be an accidental side effect of space expanding, but a fundamental part of the very nature of the cosmos. Yet this idea was largely abandoned in favor of a more linear, expanding universe. Why? Could it be that modern science, with its obsession on measurement and observation, has overlooked the ancient wisdom that saw the cosmos as a living entity? We are quick to discard the cyclical models of the past, believing them to be myths. But what if they were based on a deeper truth? Could it be that these ancient cultures had a glimpse of the universe's true nature, a nature that we are just now beginning to uncover with modern science? The cycle of creation and destruction, birth and death. This was not just philosophy for them. It was a description of the very workings of the cosmos. It was a reminder that the universe is not static, but in a constant state of flux, breathing in and out in its own time. Perhaps, in the rush to understand the universe in terms of linear time and measurable expansion, we have missed the deeper rhythm, the pulse that drives it all. But what if this ancient view of the universe isn't so far from the truth? What if the modern model of the universe, with its infinite expansion, is not the final answer, but just another phase in the eternal rhythm of the cosmos? As we shift our focus to the modern cosmology, where the universe is perceived as a rapidly expanding entity, we must ask ourselves, could there be more to this story? For all the brilliance of Hubble and Einstein, the expansion of the universe has not gone unchallenged. In fact, some of the most intriguing ideas about the universe's true nature have been buried in the margins of history, dismissed by mainstream science despite offering a wealth of potential insights. These theories were not the result of misunderstanding or lack of evidence. They were the result of intellectual rebellion. One such figure was Halton Arp, an astronomer whose observations led him to question the very foundation of modern cosmology. Arp's work centered on the idea that galaxies were not necessarily moving away from each other as the expansion model suggested. Instead, he proposed that they were being connected by streams of material, suggesting that galaxies were not separate and isolated, but in some cases were linked by a deeper, unseen force. Arp's conclusions were controversial. His observations of peculiar galaxies that seemed to defy the conventional understanding of the expanding universe, led him to propose a radically different view of the cosmos. According to Arp, the universe was not simply expanding in a uniform way. Instead, he argued that the universe's structure was far more complex, with galaxies and stars linked by forces we could not yet fully comprehend. But Arp's ideas were met with fierce resistance. The mainstream scientific community, which had already embraced the expanding universe model, dismissed his findings. His theories were sidelined, and his work was largely ignored. Despite the compelling nature of his research, Arp's ideas did not fit into the neatly packaged story that had been established by Hubble and Einstein. As a result, his work was left in the shadows, overshadowed by the growing consensus on the expanding universe. Another voice of dissent came from Georges Lemaitre, a Belgian priest and physicist who first proposed what would later become known as the Big Bang theory. Though Lemaitre is often credited with originating the idea of the expanding universe, he also suggested something that modern cosmology has largely ignored: the possibility that the universe is cyclic. Lemaitre's original conception of the Big Bang was not as a singular event, but as part of a cyclical process, where the universe would expand, contract, and then start again in a never-ending cycle. Lemaitre's vision was in stark contrast to the modern conception of the universe as a one-time event. But like Arp, Lemaitre's ideas did not gain widespread acceptance. The scientific community was more comfortable with the notion of a one-time explosion that set everything in motion. The cyclical model, though tantalizing, was dismissed as impractical, and Lemaitre's more speculative ideas were left to gather dust. It's easy to see why these ideas were rejected. After all, they didn't fit the neat narrative that had taken hold of the scientific world. But in their rejection, something significant was lost. Both Arp and Lemaitre presented ideas that challenged the status quo, forcing us to rethink the nature of the universe. What if the universe is not just expanding, but is part of a much larger, more intricate process, a process of infinite cycles, where each Big Bang is not a one-time event, but a part of an eternal rhythm? As we look at these alternative theories, we are forced to reconsider our understanding of the cosmos. Could these forgotten ideas be the key to unlocking a deeper understanding of the universe's true nature? Could they be pointing us toward a universe that is not expanding into nothingness, but cycling through endless phases of creation and destruction? Perhaps the most important question these dissenting scientists raise is this: why were their ideas so quickly dismissed? The answer may lie not in the evidence, but in the structures that govern what we consider to be acceptable knowledge. In their rejection, these ideas were relegated to the fringes of scientific discourse, where they remain largely ignored. But the very fact that they challenge the mainstream suggests they may hold the keys to a more profound understanding of the universe. A universe that is not just expanding, but breathing. As we explore these forgotten theories, we are left with the tantalizing possibility that the universe's true nature may not lie in the linear narrative we've been taught. Instead, it could be something far more complex, a process that we can only begin to comprehend as we peel back the layers of history and science. In the next chapter, we will explore some of the cosmic anomalies that challenge our current understanding of the universe. Could these mysterious phenomena be evidence of the very cycles these scientists once proposed? And if so, what does that mean for our understanding of the cosmos? When we look out into the vast expanse of space, we are not simply observing stars and galaxies. We are, in a way, listening to the echoes of the universe's earliest moments. The cosmic microwave background, or CMB, is the most ancient sound we can detect, a faint whisper from a time long before our planet, our sun, or even the galaxies we see today were born. It's the afterglow of the Big Bang, the faint radiation left behind as the universe cooled and stretched after its explosive birth. For decades, scientists have believed that the CMB was a static relic, a frozen image of the universe in its infancy, a simple, unchanging noise in the cosmic background. But what if we've misunderstood its true nature? What if this noise is not just a leftover memory, but an active, living part of the universe's ongoing rhythm? What if the CMB is not just static, but music, still playing, still echoing across the vast reaches of time? Imagine the scene. The universe, as it was just 380,000 years after the Big Bang, a roiling sea of energy, matter, and light. The air itself is thick with the heat of creation, swirling in chaotic patterns. It's a violent, untamed place, but it's also a moment frozen in time. The universe is beginning to cool. The light of the Big Bang still flickering in the background, waiting to be heard. As the universe stretches out, that energy slowly dissipates, and what we are left with is the faint hum, the CMB, still present, still vibrating in the air like the sound of a universe exhaling after its birth. For decades, this faint hum was thought to be the static remains of that early period, a reminder of the universe's birth, a snapshot of the moment when the universe became transparent to light. But then, something strange began to appear within the CMB. Tiny irregularities, tiny fluctuations began to emerge. At first, these anomalies were dismissed as noise, unexplained errors in the data or distortions from the equipment. But the more scientists looked, the more they realized that these fluctuations weren't random at all. They were consistent. They were patterns, repeating in ways that seemed to defy the idea of a simple, one-time event. In the late 1990s, astronomers detected an unusual alignment in the CMB, a curious structure that seemed to defy the principles of physics. It was as though the CMB, that faint whisper of the Big Bang, was revealing something much deeper, something we had missed. Some of these anomalies were subtle, hidden deep within the data. Others were so glaring that they couldn't be ignored. What if these weren't just random fluctuations, but echoes of something more profound, a deeper cosmic structure. The possibility that these anomalies were not random could suggest something far more profound. What if these imperfections in the CMB were not errors, but traces of past universes? What if the CMB wasn't just the afterglow of a singular, one-time event, but rather the remnants of a cyclic process, a cosmic breath, inhaling and exhaling in eternal rhythm? Could it be that the universe didn't begin just once, but rather this cycle of creation and destruction has been playing out for eons, each universe leaving behind echoes in the fabric of space and time? This idea challenges everything we've been taught about the Big Bang. The conventional view holds that the Big Bang was a singular event, the beginning of time itself, the birth of everything. But what if this is just one phase in a much larger cycle, and the CMB is not merely a snapshot of that first moment, but the ongoing whisper of the universe's endless breath? The CMB, then, becomes not just a relic from the past, but a clue, an echo that may suggest the universe has breathed before. The anomalies in the CMB could be the key to unlocking a much older, much more intricate understanding of the cosmos, one that challenges the idea of a singular beginning and hints at a repeating cyclic pattern. For the ancient cultures who saw the universe as a living entity, a breathing being, the idea of cosmic cycles was deeply embedded in their worldview. What if the CMB's irregularities are the modern-day equivalent of these ancient insights, whispers from a universe that is not just expanding, but cycling through an endless rhythm of creation and destruction? Imagine, then, that we are not just witnessing the remnants of a single cosmic event, but the pulse of a universe that has been here before and will be here again. If the universe truly breathes, if it cycles through its moments of creation, destruction, and rebirth, then the echoes of these cycles could be embedded in the very fabric of space itself, waiting to be heard. When scientists venture into the deepest reaches of the cosmos, they often expect the universe to behave in predictable ways. Our models are based on a clear set of principles: what we can observe, what we can measure. And yet, as with so many great discoveries in history, the universe has a way of revealing itself in ways that defy expectation, leaving us with questions that seem impossible to answer. In recent years, scientists have uncovered anomalies in the data that simply shouldn't exist. These irregularities challenge everything we know about the cosmos, suggesting that our understanding of the universe might be incomplete. And yet, instead of dismissing these anomalies as mere statistical flukes, some scientists are beginning to wonder if these mysterious patterns are the key to something much deeper. One of the most baffling anomalies in modern cosmology is the alignment of distant quasars. Quasars, the brilliant and distant remnants of ancient galaxies, are thought to be scattered randomly throughout the universe. And yet, when scientists examined the orientation of these quasars, they discovered something strange. Many of them appeared to be aligned along the same axis, as if the universe itself had a hidden structure, a pattern that we had failed to see. At first, this alignment was thought to be a coincidence, a fluke in the data. But the more scientists studied it, the more it became clear that this was no random occurrence. There was something deeper at play. Some researchers began to suggest that this alignment could be the result of a hidden force, something in the fabric of the universe that was shaping the very structure of space itself. Then there is the axis of evil, an even more perplexing anomaly in the CMB. The CMB, as we've discussed, is the afterglow of the Big Bang, the oldest light in the universe. It carries within it the fingerprints of the universe's earliest moments. And yet, when scientists carefully analyzed the CMB, they found an odd alignment, an axis around which the temperature fluctuations in the CMB seemed to be oddly concentrated. This alignment, known as the axis of evil, was not predicted by any of our current cosmological models. It is as if the CMB, that ancient whisper from the beginning of time, is revealing something more than we had ever expected. The axis is not random. It's not a fluke. It's a signal, a fingerprint of a deeper structure that underlies the universe itself. Could this axis, this alignment, be a clue to the universe's true nature? Could it point to the possibility that the universe isn't expanding outward into nothingness, but instead is part of a larger, more complex pattern? These anomalies are not just statistical errors or flaws in the data. They are hints, clues left by the universe itself, suggesting that our understanding of the cosmos is incomplete. These irregularities in the quasar alignment and the CMB may be the remnants of past cycles, echoes of a universe that has lived before. What if the universe is not a one-time event, but part of an eternal cycle of creation and destruction, where each cycle leaves behind clues for those who are willing to look? The implications of these anomalies are profound. They challenge our most basic assumptions about the universe, suggesting that what we see is only a small part of a much larger cosmic story. These clues, these hidden patterns, may point to a deeper understanding of the cosmos, one that has been lost, buried beneath the weight of modern scientific thinking. And as we begin to unravel these mysteries, we are forced to ask, what if these anomalies are not flaws in the data, but signs of a universe that is far more complex than we ever imagined? What if, buried deep within these irregularities, is the key to understanding the cyclical nature of the cosmos? A universe that is not expanding outward, but cycling through endless phases of creation, destruction, and rebirth. The answers may be waiting in the stars, hidden in the data, in the patterns we have yet to fully understand. As we continue to explore these anomalies, we might find that the universe is not what we thought it was. Instead, it might be far older, far stranger, and far more alive than we ever dared to imagine. In the next chapter, we will explore how ancient civilizations, who were attuned to the cosmic rhythms of the universe, may have understood these same anomalies long before modern science. Could they have seen something that we've missed? Could their ancient wisdom hold the key to understanding the true nature of the universe's cycles, long before telescopes pierced the night sky, and before modern physics unlocked the secrets of the cosmos? Ancient civilizations gazed up at the stars with a profound understanding. They didn't simply see the stars as distant lights in a darkened sky. They saw them as part of a larger, living pattern, a cosmic rhythm. To them, the universe was not a static, unchanging entity. It was breathing, pulsing, a living organism with its own cycles of life, death, and rebirth. And they understood this rhythm deeply, so much so that their timekeeping systems were rooted not in linear time, but in the very cycles of the cosmos. The Mayans, with their intricate calendars, were among the most famous of these ancient timekeepers. Their calendar systems were not just a way to track days, but a deep and spiritual reflection of the universe's cycles. The Mayans observed not just the sun, moon, and stars, but the intricate movements of planets, especially Venus, whose cycles they connected to their own cosmology. Their long count calendar, which tracked larger cycles of time, was based on the belief that the universe was governed by periods of creation and destruction. The Mayans didn't just track the days, they understood time itself as a repeating cycle, where each age had its own rhythm, and each cycle would eventually give way to the next. It was as though the Mayans were not measuring time. They were listening to it, attuned to the heartbeat of the universe. Similarly, the Vedic Indians of ancient India had their own complex understanding of time, structured around the concept of yugas, vast epochs of creation, preservation, and destruction. In the Vedic tradition, the universe was seen as going through infinite cycles, each lasting for millions of years, and at the end of each cycle, the universe would dissolve, only to be reborn again. The yugas were not merely philosophical concepts, but were reflected in their astronomical observations, which tied the movements of planets and stars to the larger rhythms of existence. The Vedic sages did not view time as linear, with a clear beginning and an inevitable end. Instead, time flowed like a great river, circling back on itself in an eternal return. The rhythm of the cosmos was not just observed, it was embodied in the culture, the philosophy, and the practices of the people. In ancient Egypt, too, the cyclical nature of the universe was embedded in the culture. The Egyptians saw the sky as a living entity, with the sun god Ra traveling through the underworld each night, only to be reborn again with the dawn. This rebirth of the sun was mirrored in the daily cycles of life, death, and renewal that were central to Egyptian cosmology. The cycles of the Nile River, which flooded and receded with the seasons, were seen as a reflection of the cosmic rhythms, and the Great Pyramids themselves were aligned with the stars in ways that reflected this deep understanding of the heavens. The Egyptians didn't just measure time, they saw it as a living, breathing force, just as much a part of their spiritual life as their physical existence. In each of these ancient cultures, there was an understanding that the universe did not simply unfold in a straight line. It was cyclical, a constant process of birth, death, and rebirth. The stars were not distant objects. They were symbols of this cosmic cycle, marking the transitions between different stages of existence. Time was not a mere sequence of events, but a pulse, a heartbeat that guided the very rhythms of life. And yet, despite the profound understanding these civilizations had of cosmic cycles, we have largely abandoned this view in favor of a more linear, modern understanding of the universe. We have come to see the universe as a series of isolated events, each star born and dying, each galaxy expanding and eventually collapsing into itself. But what if we've missed something? What if these ancient civilizations were more attuned to the true nature of the cosmos than we are? What if they understood that the universe is not a single, linear event, but a living, breathing process, one that follows a rhythm as ancient as time itself? Could it be that in our rush to understand the universe through the lens of modern science, we have forgotten the wisdom of those who saw time not as a straight path, but as a cosmic circle? The modern view of the universe's beginning, an explosive event in time, has shaped our understanding of space and time. But what if the ancient view, one of cyclical time and cosmic rhythms, is closer to the truth than we ever imagined? As we look toward the future of scientific discovery, we may begin to wonder, are we simply rediscovering an ancient wisdom? Could the pulse of the universe, the heartbeat of the cosmos, still be heard, echoing in the cosmic background radiation and in the rhythms of the planets and stars? What if the Mayans, the Vedic sages, and the Egyptians had already unlocked the secrets of the universe's true nature, long before modern science could even begin to comprehend it? The ancient world was not one of stability. It was a world of constant change, of cosmic rhythms that shaped the fates of civilizations, cultures, and worlds. These ancient peoples understood that the universe was not simply a place of creation, but also one of destruction, where death and rebirth were as essential as life itself. And in their myths, their legends, and their sacred texts, they encoded the memory of these cosmic resets, great cataclysms that shook the very fabric of the cosmos and gave rise to new cycles of existence. One of the most profound and widespread of these cataclysmic myths is the story of the flood. Across cultures, from the Sumerians to the Hebrews, from the Greeks to the Egyptians, there are stories of great floods, cataclysmic events that wiped out entire civilizations and paved the way for the birth of a new world. The flood was not just a natural disaster. It was a cosmic reset, a necessary moment in the eternal cycle of creation and destruction. In Sumerian mythology, the gods sent a great flood to cleanse the earth, destroying all life, but also providing the opportunity for new life to emerge. In the Bible, Noah's flood serves as a similar reset, wiping away the sins of humanity and allowing for a fresh start. In the Epic of Gilgamesh, the hero meets a man named Utnapishtim, who recounts a great flood that wiped out all life, a flood that was sent by the gods to destroy a corrupted world. And in ancient Greek mythology, the story of Deucalion and Pyrrha tells of a flood sent by Zeus to punish humanity, after which the couple was tasked with repopulating the earth. But what if these flood myths were not just metaphorical tales, but memories of actual events? What if they were encoded memories of past cosmic cycles, where the earth and the heavens were reset in preparation for a new age? Modern science has uncovered evidence of past cataclysmic events, mass extinction events, asteroid impacts, and pole shifts that suggest that the Earth has gone through moments of extreme upheaval, moments when entire ecosystems were wiped out and life had to begin anew. Could these ancient stories of floods, firestorms, and world-ending events be reflections of these real cosmic resets? Consider the Younger Dryas, a period around 12,000 years ago when the Earth experienced a sudden and dramatic cooling. This event coincided with the extinction of many large species, including the mammoths, and has been linked to a possible comet impact. Some researchers believe that the Younger Dryas could have been a moment of cosmic reset, a brief but intense period of destruction that brought about a new cycle of life. Could this event be the memory of the flood myth, encoded in the collective consciousness of humanity? And then there are the pole shifts, events when the Earth's magnetic poles have reversed, sometimes causing catastrophic changes in the planet's climate. These shifts, which have happened throughout the Earth's history, could also be part of the cosmic rhythm of destruction and rebirth. In ancient Egypt, the concept of Ma'at, the divine order, was understood to be in constant need of balance, and when that balance was disrupted, the world would need to be reset. The shifting of the poles could be seen as a reflection of this cosmic need for balance, a moment when the earth and the heavens realign to prepare for the next cycle. The ancient stories of world-ending floods, firestorms, and cosmic destruction may not be mere mythology, but encoded memories of real events that shaped the fate of the Earth and the universe itself. These resets may be part of a larger cosmic process, a process of creation and destruction that spans not just human history, but the history of the universe itself. What if these resets are not just the result of natural forces, but part of a larger, cyclical pattern, a cosmic breath that inhales and exhales, creating and destroying in an endless rhythm? What if the ancient stories of floods and cataclysms are not just warnings or allegories, but reflections of a deeper truth, a truth that is encoded in the very fabric of the cosmos? As we explore the patterns and geometry that govern these cosmic cycles in the next chapter, we will begin to see that these events are not random. They are part of a grand design, a pattern that repeats across time and space, shaping the very structure of the universe. The question then becomes, what is the purpose of this cosmic rhythm? And how does it relate to the cycles of life, death, and rebirth that we see not only in the heavens, but on Earth as well? The answers may lie hidden in the very fabric of the universe itself, waiting to be discovered. There is a strange beauty in the way the universe unfolds, its structure, its patterns, its order. We often speak of the chaos of the cosmos, the vast, seemingly endless expanse of stars, planets, and galaxies. But what if this chaos, this vastness, is not random? What if, hidden in the fabric of the universe, there exists an underlying order, a blueprint that shapes everything we see? It's easy to imagine that the universe is a mess of disordered particles, clashing galaxies, and cosmic chaos. And yet, when we step back and observe the larger patterns, when we study the shapes and structures that emerge from the depths of space, we begin to see something else entirely: geometric perfection. From the swirling spirals of galaxies to the elegant curves of planetary orbits, the universe reveals itself in forms that echo the symmetry of sacred geometry, a timeless language that connects the cosmos to ancient human understanding. One of the most striking examples of this cosmic geometry is the golden ratio. This mathematical concept, revered by ancient civilizations for its aesthetic and symbolic significance, appears not just in art, architecture, and nature, but also in the structure of the universe itself. The spiral arms of galaxies, such as the Milky Way, follow the same pattern that we find in the Nautilus shell, a pine cone, or the petals of a flower. The golden ratio, roughly 1.618, appears time and time again in the way natural systems organize themselves, from the smallest cellular structures to the largest cosmic formations. Take the spiral galaxies that dominate our night sky. Their arms twist outward in a shape that is remarkably consistent with the logarithmic spiral, a curve that approximates the golden ratio. The idea that this particular pattern could arise organically from the interactions of gravitational forces is fascinating, yet it raises a profound question. Why this pattern? Why does the universe favor a shape that humans have regarded as so universally pleasing and harmonious? But it doesn't end with galaxies. the phenomenon of gravitational lensing, when massive objects like galaxies bend the light of stars behind them, also follows geometric principles. Light, which travels in straight lines through space, is distorted by the gravitational pull of objects it passes. This bending forms arcs and shapes that are not just random distortions, but perfectly predictable patterns that follow the laws of physics. As we peer deeper into space, we find that light, shaped by gravity, forms geometric structures that reflect the inherent order of the universe. This interplay of science and geometry does not stop with the visible universe. It extends deep into the very foundations of physics. Modern astrophysics, from the study of black holes to the exploration of string theory, reveals a universe that is shaped not by arbitrary forces, but by an intricate, underlying symmetry. The equations that govern the laws of physics, the laws that define how galaxies form, how stars burn, and how light behaves, are themselves a kind of mathematical language, one that is grounded in patterns of symmetry and harmony. When we look at the universe through the lens of sacred geometry, we begin to ask ourselves, is there a deeper reason for these patterns? Ancient cultures believed that these geometric forms were not just random occurrences, but reflections of a divine order. In ancient Egypt, the proportions of the pyramids were based on sacred geometry, aligning them with the stars and the natural world. The Greeks, too, revered the golden ratio, seeing it as a key to understanding the structure of the cosmos. To them, the universe was not a chaotic accident. It was a cosmic design, a structure that could be understood through the principles of geometry. In modern times, we have come to see the universe as something more mechanical, governed by physical laws and mathematical equations. But perhaps, as we delve deeper into the cosmic patterns, we are rediscovering something that the ancients already knew: that the universe is not just a collection of random particles and forces. It is a living, breathing work of art. It is a cosmic blueprint, one that we are only just beginning to decipher. As we look deeper into the universe, we start to see the traces of this sacred geometry everywhere. In the way galaxies form, in the way light bends, in the way particles interact on the quantum level. Each of these phenomena speaks a language of mathematical elegance. The universe, it seems, is not just a place of random events. It is a work of art, painted with the brushstrokes of cosmic geometry. So, if the universe follows a geometric blueprint, what does this mean for our understanding of reality? Does it suggest that the universe itself is a conscious entity, one that knows its own design? Or is it simply a reflection of the mathematical order that underpins the very fabric of existence? These are the questions that draw us deeper into the mystery of the cosmos. As we continue to explore the universe's geometry, we may uncover more clues, more patterns that help us understand not just how the universe works, but why it works the way it does. The geometry of the universe, then, is not just an aesthetic curiosity. It is a key to understanding the very nature of existence. As we peel back the layers of the universe's geometric design, we are led to a deeper question. What if the universe is more than just a physical system? What if it carries memories of its past, encoded within the very fabric of space and time? This idea, though speculative, offers a profound way of understanding the cosmos, not just as a physical structure, but as a living, breathing entity that carries the echoes of its past cycles. Imagine for a moment that the universe itself possesses a kind of memory, not in the way that humans remember, but in a more abstract sense. What if, as the universe expands, contracts, and evolves, it leaves behind traces, residues of its previous states, etched into the very laws that govern it? This concept is not as far-fetched as it might seem. In fact, it draws on theories from both modern physics and metaphysical traditions, offering a unique perspective on how the universe might remember its past. One theory that hints at this idea is Rupert Sheldrake's concept of morphic resonance. Sheldrake proposes that just as biological forms are shaped by past patterns of growth, so too is the universe shaped by the memories of its past. The idea is that each cosmic event, the formation of a star, the birth of a galaxy, leaves an imprint, a kind of memory that influences the future. These imprints are not physical objects, but resonant patterns that persist through time, influencing the behavior of future systems. In this way, the universe is constantly remembering its past, and those memories shape the present. This concept aligns with another mysterious aspect of modern physics: quantum entanglement. In quantum mechanics, particles that are entangled remain connected even when they are separated by vast distances. A change in one particle instantly affects the other, no matter how far apart they are. This suggests that the universe is not made up of isolated, independent events, but of interconnected systems where each moment is linked to the past. Could this connection, this entanglement, be a form of cosmic memory? A memory that is embedded in the very fabric of space-time. If the universe carries a memory, what does this mean for us? Could our consciousness be attuned to this cosmic memory field? In some metaphysical traditions, consciousness is not seen as something that emerges from the brain, but as something that is connected to the greater universe, a reflection of the universal mind. In this view, our thoughts, our memories, and even our sense of self might not be entirely our own. They might be echoes of the universe's past, reverberations of cycles long forgotten. This speculative idea draws on the notion that consciousness is not simply a byproduct of the brain's neural activity, but a fundamental part of the cosmos itself. If the universe has a memory, then perhaps our thoughts, our insights, and our intuitions are not just the result of biological processes, but are connected to a deeper, universal memory field, a field that stretches across time and space, carrying with it the imprints of past cycles. In this context, our consciousness is not separate from the universe. It is a part of it, an expression of the universe's own memory. Each thought, each perception, is a resonance of the cosmic patterns that have come before us. We are not just observers of the universe. We are participants in its ongoing memory, connected to the cycles that shape it. As we consider the implications of this idea, we begin to see the universe in a new light. It is not just a collection of stars and galaxies, expanding and contracting according to the laws of physics. It is a living, breathing entity, one that carries within it the echoes of its past, and one that shares its memory with all who are attuned to its rhythms. Our consciousness, then, is not just a fleeting spark in the darkness. It is a part of the universe's ongoing process, a process that stretches across time, linking past, present and future in a continuous flow of memory and renewal. In the next chapter, we will explore some of the forgotten theories of the universe, ideas that have been overlooked or erased by mainstream science. Could these theories hold the key to understanding the cyclical nature of the cosmos and the memory that resides within it? The answers may lie buried in the history of scientific thought, waiting to be rediscovered. The story we are told about the universe, the Big Bang, the expanding cosmos, the birth of galaxies, is a story that has shaped our understanding of reality for decades. It is a story that seems as solid as the stars themselves, supported by evidence and established by the giants of science. But what if this story we cling to, this narrative we have been taught to accept without question, isn't the only one? What if there were other theories, once prominent and promising, that challenged the Big Bang model? Ideas that were pushed aside, forgotten, and even erased from the collective scientific memory. The universe, we are told, began in a moment of explosion from an infinitely small point and has been expanding ever since. But this view, though compelling, was not the only interpretation of the cosmos. In fact, there were once alternative models that provided a very different perspective on the universe. A perspective that was eventually overshadowed by the rising dominance of the expanding universe theory. Take, for example, the steady-state theory, proposed in the mid-20th century by cosmologists like Fred Hoyle. This theory posited that the universe had no beginning and no end, unlike the Big Bang, which suggests a single moment of origin. The steady-state theory proposed that the universe is eternal, constantly creating new matter as it expands. In this view, the cosmos was not a temporary event, but an eternal, unchanging entity, forever in balance. It was a universe that simply was, a vast and unbroken expanse of matter, where new galaxies were born and old ones faded away. But the universe itself remained constant. At first, the steady-state theory garnered a great deal of attention and respect. It was seen as a promising alternative to the Big Bang model, one that seemed to fit with the idea of an eternal, unchanging universe. Yet, over time, the theory was slowly pushed aside, overshadowed by the growing evidence supporting the Big Bang. The discovery of cosmic background radiation in the 1960s, which could not be explained by the steady-state theory, dealt a decisive blow to the model, pushing it into the margins of cosmological thought. But was this theory truly wrong, or was it simply replaced by a more fashionable narrative? Alongside the steady-state theory, there were other models that questioned the Big Bang. Plasma cosmology, for example, proposed that the universe's large-scale structure was shaped not by gravity alone, but by electromagnetic forces. According to this theory, the plasma that fills the cosmos played a crucial role in shaping galaxies, stars, and even the cosmic web. Plasma cosmologists argued that the universe was not merely expanding from a singular point, but was instead in a dynamic state of interplay between electromagnetic and gravitational forces. While plasma cosmology offered a plausible explanation for many cosmic phenomena, it too was quickly sidelined by the scientific mainstream. With the rise of the Big Bang model and the establishment of dark matter and dark energy as the dominant forces shaping the universe, theories like plasma cosmology struggled to gain traction. The mainstream narrative had already been set, and any theory that deviated from that narrative was quickly dismissed as unconventional or unscientific. Perhaps the most controversial and daring alternative theory to the Big Bang came from the proponents of the electric universe model. This theory proposes that electricity, rather than gravity, plays a central role in shaping the universe. According to this model, the universe is not a place where gravitational forces dominate, but rather one where electromagnetic forces are the primary drivers of cosmic evolution. The electric universe model suggests that stars, galaxies, and even black holes are shaped by vast electrical currents, and that the universe itself is a complex electrical circuit. This theory, though compelling to some, has been largely dismissed by the scientific community. It presents a radically different view of the universe, one that challenges our fundamental understanding of physics. And yet, the electric universe model has not disappeared. It still has proponents who continue to question the prevailing narrative and argue for a more electrically driven cosmos. These theories, steady state, plasma cosmology, electric universe, were not just dismissed on the basis of evidence. They were buried under the weight of a scientific culture that had already decided on the story of the Big Bang. There is no denying that the Big Bang theory was a groundbreaking discovery, supported by a wealth of evidence, from the red shift of galaxies to the cosmic background radiation. But what happens when science becomes more about confirming an established narrative than about seeking the truth, no matter where it leads? In many ways, the dismissal of these alternative cosmologies highlights a fundamental problem in science: the tension between exploration and conformity. When new ideas arise that challenge the established order, they often face intense resistance, not because they are necessarily wrong, but because they threaten to destabilize the status quo. The gatekeepers of scientific thought, the institutions, the funding bodies, the influential scientists, often have much to lose when new ideas threaten the established narrative. And so, these alternative theories are marginalized, forgotten, and erased from the mainstream scientific discourse. But in their erasure, we lose something vital. The scientific community is not just a collection of experts. It is also a reflection of the culture that shapes it. And when certain ideas are suppressed, we risk limiting our understanding of the universe. What if, in our desire for certainty and clarity, we have missed out on a more complex, more profound understanding of the cosmos? What if the universe didn't change, but the story we chose to tell about it did? The suppression of these alternative models raises a question that cannot be ignored. Who controls our understanding of the cosmos? Who gets to decide which theories are worthy of exploration, and which ones are relegated to the margins of history? In the next section, we will explore this question more deeply, as we look at the power structures behind scientific consensus and how they shape the truth about the universe. The world of science is often portrayed as a realm of objective truth, a place where evidence reigns supreme, and theories are accepted or rejected based solely on their merits. But in reality, science is not just about data and observations. It is deeply influenced by the power structures that govern the flow of knowledge and the direction of research. From funding agencies to university boards to the media, there are numerous forces at play in shaping what we understand to be true about the universe. These forces, often invisible to the public, help decide which theories gain traction and which ones are left in the shadows. The most powerful institutions in science are not always the ones that produce the most groundbreaking discoveries. In fact, they are often the ones that preserve the established narrative, protecting the current paradigm from ideas that might disrupt it. Funding agencies, which provide the financial support for scientific research, play a key role in shaping what is studied and how it is studied. Researchers who want to secure funding for their projects often have to align their work with the dominant scientific worldview. And those who challenge that worldview may find themselves without the resources or the platform to present their ideas. In addition to funding, the peer review process plays a crucial role in determining which ideas make it into the scientific mainstream. While peer review is essential for ensuring the quality of a research, it can also be a powerful tool for maintaining the status quo. Scientific journals, which are often the gatekeepers of knowledge, are reluctant to publish research that challenges the dominant theories. In this way, scientific progress can sometimes be held back by the very system that is supposed to encourage it. The media, too, plays a significant role in shaping public perceptions of science. When a new discovery is made, the way it is framed in the media can have a profound impact on how it is received by the public and the scientific community. Scientists who are able to communicate their ideas effectively can gain widespread support, while those who propose unconventional theories may be dismissed or ignored. This intersection of science and power has far-reaching implications. It raises questions about how knowledge is controlled and whose interests are served by the prevailing scientific narratives. Science, like any other institution, is not immune to the biases and power structures that shape society. And in the world of cosmology, where the stakes are high and the questions are profound, these biases can have a profound impact on the direction of research. Consider the alternative cosmological models that were dismissed by the scientific establishment. Ideas like steady-state theory, plasma cosmology, and the electric universe. These theories were not rejected solely because they lacked evidence. They were rejected because they did not fit within the prevailing scientific framework. And in many cases, the dismissal of these theories was not a matter of objective analysis, but a result of the political and cultural forces that govern the scientific community. The question, then, is not just about which theories are correct, but about who gets to decide what is worth exploring. Who defines the boundaries of scientific inquiry? Who decides what is acceptable knowledge and what is not? In many ways, science is shaped not just by the data, but by the institutions and power structures that control the flow of knowledge. As we consider the ways in which scientific knowledge is shaped by power, we are forced to ask, what if the truth about the universe is not as clear-cut as we've been led to believe? What if the dominant scientific theories are not the final word, but simply the result of a particular cultural moment? What if, in the rush to find certainty, we have overlooked other possibilities that challenge the very foundations of our understanding? In the next chapter, we will explore a new cosmological model, the concept of a breathing universe. This model, though unconventional, offers a radically different view of the cosmos, one that aligns with some of the ancient ideas we have discussed. It suggests that the universe is not just a place of random events, but a living, breathing entity that cycles through endless phases of creation, destruction, and rebirth. Could this idea be the key to understanding the true nature of the cosmos? We will explore this possibility in the next chapter, as we continue to question the stories we have been told about the universe and the forces that shape them. There is a deeply unsettling thought that arises when we consider the true nature of the universe and our place within it. What if consciousness itself is not separate from the universe, but an integral part of it? For centuries, we've been taught that consciousness is a byproduct of the brain, that it arises from the physical processes within our heads and is confined to the boundaries of our bodies. But what if this understanding is incomplete? What if consciousness is not merely a product of neural activity, but something far more profound, something that interacts with the universe itself? To explore this idea, we must first turn to the field of quantum mechanics, where the rules of reality are far more fluid and strange than in the everyday world. Quantum physics tells us that the very act of observing something affects its state. This is known as the observer effect, a phenomenon where particles behave differently when they are being measured or observed. It's as if the very act of observation causes the universe to choose a state, collapsing the possibilities into a single, definite reality. Now, consider this. If consciousness can influence the behavior of subatomic particles, shaping the very fabric of reality through observation, does this suggest that consciousness is not just a passive observer, but an active participant in the unfolding of the universe? Could it be that our awareness, the very act of perceiving, has the power to shape the world around us? The implications of this are profound. It challenges the long-held belief that consciousness is something separate from the world, a byproduct of the brain's complex functions. Instead, it proposes that consciousness is not just something we experience. It is something that interacts with the cosmos itself, shaping the unfolding of reality as we observe it. This idea suggests that the universe may not be a passive backdrop to our existence, but an active participant in the experience of consciousness. This concept is not as new as it might sound. Ancient philosophies, particularly Vedanta in Hinduism, have long taught that the universe and consciousness are inseparable. In Vedantic thought, the universe is seen as a manifestation of consciousness, and everything, every star, every galaxy, every particle of matter is a reflection of that consciousness. There is no separation between the observer and the observed. The universe itself is an expression of universal awareness. In this view, consciousness is not confined to the brain or to individual minds, but is a fundamental part of the universe, pervading all of existence. In a sense, we are not simply in the universe. The universe is in us. The very act of perceiving, of observing the world around us, is a reflection of the universe experiencing itself. Our awareness may be the lens through which the cosmos becomes aware of itself. In this framework, consciousness becomes a central force in the unfolding of the universe's story, guiding its evolution and shaping its reality. This understanding of consciousness is radically different from the materialistic view that sees it as an accident of biology, a function of the brain's neural networks. Instead, it suggests that consciousness is a fundamental property of the universe, a force that interacts with the fabric of reality itself. Just as gravity shapes the movement of stars and galaxies, consciousness shapes the way the universe unfolds, allowing it to experience itself through the awareness of individual beings. The quantum observer effect points to a deeper connection between consciousness and reality. The universe, it seems, does not exist independently of us. It is shaped by our observation, influenced by our awareness. And if this is true, then perhaps the universe is not just expanding endlessly into the void, but becoming aware, growing, evolving, and learning through its interactions with conscious beings. What if the universe isn't just expanding, but becoming aware? What if the growth of the universe, its expansion and transformation, is not just a physical process, but a process of self-awareness? Just as an individual's consciousness evolves over time, could the universe itself be evolving, learning about its own nature through the awareness of the beings that inhabit it? These are questions that challenge our conventional understanding of the cosmos. If consciousness is not separate from the universe, if it is an active participant in the unfolding of reality, then the entire nature of existence changes. We are no longer passive observers of a vast, indifferent universe. Instead, we are part of a living, breathing cosmos, one that is shaped by our awareness and guided by our perception. This understanding opens up a whole new way of thinking about the universe and our place in it. If we are not separate from the cosmos, if our consciousness is a reflection of the universe's own awareness, then perhaps the universe is not as cold and indifferent as we once thought. Instead, it is a living entity, evolving through its interaction with conscious beings like ourselves. As we continue to explore the relationship between consciousness and the cosmos, we are led to a deeper question. What role does our awareness play in the unfolding of the universe's story? If the universe is becoming aware of itself through consciousness, what does this mean for our understanding of reality? And how can we align ourselves with this cosmic rhythm? In the next section, we will explore the idea that the universe's cyclical nature is driven by a desire for self-awareness. Could consciousness itself be the force that drives the evolution of the cosmos, helping it to understand itself more deeply with each cycle? What if, through our awareness, we are not only participating in the universe's evolution, but are an essential part of its unfolding story? What if consciousness is not just a byproduct of the brain, but a fundamental force that shapes the cosmos? This question takes us deeper into the idea that the universe's cyclical nature is not random, but driven by a desire for self-awareness. Could it be that the universe breathes not just to create and destroy, but to evolve and understand itself through each cycle? If consciousness is an inherent part of the universe, then perhaps the entire process of cosmic expansion and contraction is not just a physical phenomenon, but a reflection of the universe's quest for self-awareness. The universe may breathe in cycles not just to create new galaxies or stars, but to experience itself more fully, to understand its own nature in a deeper way. Each phase of expansion could represent the universe's attempt to understand itself in new ways, while each phase of contraction could be a time of introspection, a moment for the cosmos to reflect on what it has learned. This perspective challenges the traditional view of the universe as a mechanical, impersonal system governed by physical laws. Instead, it suggests that the cosmos is alive with purpose, that it has an inherent drive to know itself, to experience its own existence. Just as we, as conscious beings, seek understanding and growth, the universe may also be on a journey of self-discovery. In this model, consciousness is not confined to human beings or even to life as we know it. It is a universal force, embedded in the very fabric of the cosmos, shaping the way the universe unfolds. Our awareness, then, is not separate from the cosmos. It is a reflection of the universe's own self-awareness. Just as the cells of our body are part of a larger whole, so too are our minds part of the greater consciousness that pervades the universe. As the universe cycles through its phases, it learns, it evolves, and it becomes more aware of its own existence. Each cycle of creation and destruction is not just a physical process, but a step in the universe's quest for understanding. The universe may not be expanding aimlessly into the void. It may be expanding to learn, to experience new possibilities, and to deepen its awareness of itself. In this view, we are not merely passive observers of the universe. We are participants in its ongoing evolution. Our consciousness is not just an isolated phenomenon, but a reflection of the cosmic consciousness that drives the universe's cycles. We are not just living in the universe. We are part of its ongoing story, helping it to understand itself through our awareness. What if, then, the question of the universe's purpose is not about creating matter, energy, or life? Perhaps the true purpose of the universe is to experience and understand itself. Perhaps the universe's breath is not just a cycle of physical processes, but a cosmic search for self-awareness. As we reflect on this idea, we must ask, what does this mean for us? If we are part of this cosmic consciousness, then how does our awareness fit into the larger story of the universe? Are we simply reflections of the universe's quest for self-understanding, or are we active participants in shaping its future? The answers to these questions will guide us as we consider our place in the cosmic rhythm. In the next chapter, we will explore our role in the cosmic cycle, reflecting on how we are not just passive observers, but integral parts of the universe's ongoing breath. The universe's search for self-awareness is not just a distant concept. It is something that we, too, are part of. Together, we will explore how the pause between breaths might offer us a deeper understanding of our connection to the cosmos. The universe, vast and ever-expanding, has been steadily stretching for nearly 14 billion years. But now, in the most distant reaches of space, something strange is happening, something that suggests the universe may be on the brink of a monumental shift. We've long thought of cosmic expansion as an irreversible process, with galaxies speeding away from each other, their motions dictated by a universe that was born in the Big Bang. But what if this expansion is beginning to slow down? What if, instead of continuing to stretch outward, the universe is poised to shift gears into contraction, a moment of cosmic collapse before the next inhale in the cycle of life? For years, scientists have observed the universe expanding at an accelerating rate. Dark energy, the mysterious force driving this acceleration, has been the explanation offered for this strange phenomenon. But recent data has begun to suggest that this acceleration may not be as relentless as we once believed. In fact, some of the latest findings from distant galaxies and supernovae are pointing to a potential slowing in the rate of expansion. The universe, it seems, may be entering a turning point. What could this shift mean for the future of the cosmos? If the expansion is indeed slowing, does this signal the beginning of the end of this cosmic phase? Could we be on the cusp of a new chapter? One where the universe begins to contract, folding back in on itself in a great cosmic inhale, preparing for the next great cycle. These questions have profound implications, suggesting that we are not merely witnessing an isolated moment in cosmic history, but are at the threshold of a larger, cyclical process. Perhaps the most striking of these anomalies is the changing behavior of distant supernovae. Supernovae, which are the explosive deaths of massive stars, have been used as standard candles to measure the distance and velocity of galaxies. Their brightness has helped astronomers track the rate at which the universe is expanding. But some of the latest supernova observations have shown slight deviations in their brightness, suggesting that the rate of expansion may be slowing. This change, if confirmed, could indicate that the universe is no longer stretching outward at the same pace, hinting at the possibility of a cosmic turning point. Additionally, some recent observations of distant galaxies have shown irregularities in the way they move. For years, the prevailing belief was that galaxies, on average, were speeding away from each other due to the expansion of space. But new data from galaxy clusters suggests that some galaxies are moving more slowly than expected, and in some cases, even moving toward each other. If these observations hold up, it could mean that the universe is transitioning from an expanding state to one of contraction, a process that has not been seriously considered in modern cosmology for decades. In the context of the breathing universe model, these anomalies are particularly significant. If the universe is indeed cyclic, then the slowing expansion may signal the beginning of the contraction phase, the cosmic inhale that follows the exhale of expansion. For this cycle to continue, the universe must not just expand forever, but also contract, drawing all matter and energy back into itself before the next Big Bang or birth of a new universe. This idea, though speculative, offers a radically different view of the universe's future. Instead of a never-ending expansion into the cold, empty void, the universe might be preparing for a new phase, a contraction that could reorganize matter and energy, setting the stage for another cycle of creation. This shift in perspective opens up the possibility that the universe is not just a one-time event, but part of an ongoing process, one that has no beginning and no end, but rather a continuous rhythm of expansion and contraction. If the universe is truly holding its breath, what happens next? How will we know when the universe begins to inhale once again? And what will this cosmic shift mean for life, for the very fabric of existence? The answer may lie in the next phase of the cosmic cycle, one that we are only beginning to understand. As we approach this moment of cosmic transition, it's worth reflecting on the implications of this shift, not just for the universe, but for us. The possibility of contraction suggests that the universe is not a random collection of matter, but a living entity that follows a cosmic rhythm, breathing in and out in a way that we are just beginning to perceive. And if this is true, what role do we play in this grand cycle? Are we simply observers, or are we participants in the cosmic dance? These are questions that will shape our understanding of the universe's future and our own place within it. The section closes with a powerful question. If the universe is transitioning, What will happen during this contraction phase? What does it look like when the cosmos begins to fold back in on itself, when it inhales before the next great exhale? The next section will explore these questions, speculating on the potential nature of the contraction phase and what it could mean for the universe and for us. As we stand on the cusp of this cosmic turning point, one question remains. What happens during the contraction phase? If the universe is about to inhale, folding back in on itself, what will this look like? And what does it mean for the very fabric of reality? To understand this cosmic exhale, we must rethink our conventional ideas of collapse and destruction. The traditional view of contraction, of the universe collapsing in on itself, has often been framed as a cataclysmic end. When we think of collapse, we imagine something destructive, a violent implosion where all matter and energy are crushed into a singularity. The idea of the Big Crunch, where the universe contracts into a dense, infinitely small point, has been a popular theory in cosmology for years. But what if collapse isn't the end, but a necessary phase of reorganization? What if, instead of a destructive force, contraction is a process that prepares the universe for renewal, for a new cycle of creation? Consider the process of condensation. When a cloud condenses, it doesn't destroy itself. Instead, it reorganizes, pulling together moisture from the atmosphere and forming raindrops. The process of contraction in the universe may not be about destruction, but about bringing everything together to prepare for the next great expansion. Just as a raindrop forms from condensation, the universe may contract to reorganize itself, setting the stage for the next cycle of creation. This view challenges the traditional understanding of collapse as something catastrophic. Instead, contraction becomes a phase of cosmic refinement, a simplification that clears the way for new forms to emerge. Matter becomes denser, more concentrated, as the universe sheds what is no longer needed, preparing itself for the next inhale. This moment of contraction could be a necessary process, one that creates the conditions for new life, new galaxies, new stars, to emerge in the next phase of expansion. But what would this contraction look like on a cosmic scale? Imagine a universe where galaxies, once spread out across the vastness of space, begin to draw closer together. Gravity pulls matter into more concentrated structures, collapsing the vast voids between galaxies. Stars burn more intensely as they consume the last remnants of matter, and black holes grow larger, swallowing everything in their path. The universe, once so sprawling and expansive, begins to shrink, drawing everything back into a singular point of dense, concentrated energy. But this is not an apocalyptic scenario. It is a moment of cosmic reorganization, a chance for the universe to shed what is unnecessary and prepare for the next phase of creation. The universe's death in this phase is not an end, but a clearing of space, a preparation for the next great breath, the next Big Bang. In our human experience, we can relate to this process of expansion and contraction. Think of the ebb and flow of life, how we experience moments of growth, of expansion, where our lives feel full and limitless, followed by moments of contraction, when we retreat, reflect, and prepare for new growth. These phases are not random or destructive. They are part of a natural rhythm that is necessary for balance and renewal. Just as the universe breathes in and out, we too experience cycles of expansion and contraction. There are moments when we expand into new ideas, new relationships, new challenges, and moments when we retreat, reassess, and regroup. These periods of contraction are not the end. They are part of the process of growth. The universe, like us, needs these phases of contraction in order to realign, to reorganize, and to prepare for the next wave of creation. As we reflect on this process, we are left with an important question. If the universe is contracting, what does that mean for us? How do we fit into this grand cosmic cycle? Are we simply spectators of this cosmic rhythm? Or are we an integral part of it, experiencing the same cycles of expansion and contraction on a personal level? The answer may lie in the deep connection between human consciousness and the cosmos, a connection that links us to the eternal rhythms of the universe. In the next chapter, we will explore this relationship further, examining how consciousness itself might be connected to the cosmic cycle. Are we simply aware of the universe's cycles, or is there a deeper, more intimate link between us and the cosmos? The answers may help us understand our place in this grand, eternal rhythm, in the vast, dark expanse of space, where galaxies spin like pinwheels and stars are born and die in the blink of an eye. There's an unsettling thought that beckons us. What if the universe is not expanding endlessly, as we've been taught, but is instead cycling through a process of life, death, and rebirth? What if the Big Bang wasn't the beginning of everything, but simply one breath, one inhale in a cosmic process that is eternal, a rhythm of creation and destruction that spans beyond time itself? Imagine for a moment that the universe is not a static, one-time event. Instead, it is a living organism, pulsing in and out, breathing in an eternal rhythm. Each cycle, each exhale, could mark the death of one universe, followed by the birth of another. The Big Bang, as we have come to understand it, would then be nothing more than the first breath after the last exhale. It's not the birth of the universe, but a new phase in its eternal cycle of creation. This idea isn't as far-fetched as it might sound. Modern cosmology, particularly the bounce theory, suggests that the universe could be cyclical, a series of bounces where the universe expands, contracts, and eventually re-expands in a perpetual cycle. According to this theory, the Big Bang wasn't the beginning of time, but rather the result of a contraction phase, where the universe collapsed into a singularity before bursting outward once more. In this model, entropy, the measure of disorder, becomes something much less terrifying. It's not a force that signals the universe's inevitable death, but a natural process of reorganization. Each contraction and expansion is part of a grand cosmic reset, a breath that reorders the universe before it begins again. But how can we begin to grasp this idea, one that challenges everything we've been taught about the universe? To understand the concept of a breathing universe, we must first consider the nature of life itself. All living things breathe. The rhythm of breath, inhale and exhale, is what sustains life. When we breathe, we take in oxygen, bringing in what is needed to fuel our body, and then exhale, releasing what no longer serves us. This process repeats day after day, sustaining life in a rhythm that is as natural as it is essential. Now, imagine the universe as a living being, where each breath is a moment of creation and destruction. The cycle of expansion and contraction. The process of the universe's breath becomes not just a physical event, but a fundamental force that drives the cosmos. When we look at the stars, we are not simply seeing a random collection of burning gas and light. We are witnessing the exhalation of the universe, the release of energy that forms the galaxies, the stars, and everything in between. And as the universe contracts, it inhales the energy back in, preparing for the next cycle. This view of the universe is not just a poetic metaphor. It finds resonance in ancient philosophies as well. In many spiritual traditions, the universe is seen as a living, breathing entity. The ancient Vedic texts describe the cosmos as a cyclical process of creation and dissolution, with each cycle governed by a cosmic breath. The same idea appears in the Egyptian and Greek philosophies, where the gods themselves are seen as breathing life into the cosmos in a continuous rhythm. What if modern physics is beginning to rediscover what ancient civilizations knew long ago? What if the idea of the Big Bang as a singular, one-time event is a limited interpretation of a much grander, cyclical process? The breath of the universe, much like the breath of a living being, doesn't stop at a single event. It continues, unfolding through infinite cycles of creation, death, and rebirth. In this view, the expansion of the universe is not the beginning of a journey into endless emptiness. It is part of an ongoing cycle of life, a cosmic rhythm that stretches across time and space. The idea that the universe is alive, breathing, pulsating with life, brings a new depth to our understanding of the cosmos. It is not just a place of stars and galaxies, but a living entity in its own right, following a blueprint that has been unfolding since time itself began. So, what if the Big Bang wasn't a birth? What if it was just one breath, a cosmic exhale, followed by another inhale, the universe expanding and contracting forever? The very nature of time and space might not be as we've imagined. Instead of a linear march from birth to death, the universe may instead follow a rhythm of perpetual cycles, a cosmic dance that never ends. This perspective doesn't erase everything we've learned about the universe. It doesn't invalidate the Big Bang or the expansion we see around us. Instead, it offers us a new way of understanding it. If the universe breathes, if it cycles through creation and destruction, then our current understanding may only represent one moment in an infinite cosmic loop. If the universe truly breathes in cycles, then each breath leaves behind traces, echoes that reverberate through time and space. Just as the breath of a living being leaves behind a momentary imprint in the air, so too do the cycles of the universe leave their mark on the fabric of existence. These traces, these remnants, may be the clues we need to uncover the true nature of the cosmos. Consider the cosmic microwave background, CMB, the faint radiation that fills the universe. For years, scientists have regarded the CMB as the remnant of the Big Bang, the afterglow of the universe's fiery birth. But what if the CMB is not just the leftover heat from a singular moment in time, but the echo of a previous universe's breath? What if the radiation we detect is not merely the residue of the Big Bang, but a trace left behind by an earlier cosmic cycle, an exhale from a universe that existed before ours? The CMB has been studied for decades, revealing a wealth of information about the early universe. It tells us about the conditions that existed just moments after the Big Bang, when the universe was young and full of energy. But hidden within this background radiation are anomalies, fluctuations, irregularities that don't fit neatly into the current model of an ever-expanding universe. These anomalies could be more than just statistical noise. They could be the remnants of past cycles, cosmic fingerprints that have been left behind by previous iterations of the universe. In the same way that we leave behind footprints in the sand, each cosmic cycle leaves behind traces in the fabric of space-time. These imprints may take the form of subtle irregularities in the CMB, anomalies in the distribution of galaxies, or even shifts in the constants of nature, such as the speed of light. Could these irregularities be evidence of the universe's cyclical nature? Could they be clues pointing to the fact that the cosmos has lived before and will live again? One intriguing piece of evidence lies in the distribution of galaxies themselves. When we look at the large-scale structure of the universe, we see a pattern, a vast cosmic web where galaxies are arranged in clusters and voids, stretching across the universe like a giant net. But this pattern isn't entirely random. The distribution of galaxies appears to be influenced by forces that go beyond mere gravitational attraction. There are features in the cosmic web that suggest the universe is not just a random collection of matter, but a system that has been shaped by previous cosmic events. These features may be the remnants of past cosmic cycles, imprints left behind by previous exhales. In addition to the CMB and the cosmic web, there are also hints that the laws of physics themselves might carry traces of past cycles. The constants of nature, the speed of light, the strength of gravity, are thought to be fixed, unchanging throughout the history of the universe. But what if these constants are not as constant as we believe? What if they are influenced by the previous cycles of the universe, gradually shifting as the universe evolves and breathes in and out? Some physicists have suggested that the constants we observe today could be different from those in past cycles, a subtle reminder that the universe is not a static entity, but one that is constantly reordering itself. As we explore these traces of past cycles, we are confronted with the possibility that the universe is not just a single linear event. It is part of a much larger, more intricate process, an eternal cycle of creation, destruction, and rebirth. The traces left behind by past cycles may be the key to understanding the true nature of the cosmos and the way it breathes in and out, expanding and contracting in an endless dance of life. But what does this mean for us, for our place in the universe? If the universe has lived before, if it has breathed in and out across infinite cycles, then where do we fit into this grand rhythm? Are we simply the latest in a long line of fleeting moments? Or are we part of a larger cosmic process that stretches beyond our understanding? In the next chapter, we will explore where we are in this great cosmic cycle. Are we on the brink of the next phase, the next inhale in the universe's eternal breath? The answers may lie in the very patterns and anomalies we've uncovered, traces of a universe that has lived before and will live again. In the stillness of the cosmos, before the universe takes its next great breath, there is a pause. It is a moment between moments, suspended in time, a silence that pervades the vastness of existence. The stars continue their dance, the galaxies spin, yet in this moment of stillness, there is something profound happening, not in the visible, not in the loud, but in the quiet. It's a kind of cosmic pause, a space between the great exhale of the universe and the next inhale. We can almost feel it if we listen closely enough. An anticipation, a waiting, as if the universe itself is gathering its energy for the next act of creation. This pause is often overlooked. We focus on the moments of action, of creation, of the Big Bang, the expansion, the birth of stars and galaxies. We think of the universe as constantly moving, constantly evolving, never stopping. But the universe's rhythm, its cosmic heartbeat, is not defined only by the moments of expansion or contraction. There are pauses in between, and in those pauses lies the potential for all that comes next. It is in the stillness, in the silence, that the universe prepares for its next great cycle. And, like the pause between our breaths, it holds the promise of what is to come. Consider the cycles of our own lives, how moments of rest, of pause, are as vital as the times of action. Our lives are not only about what we do, but about how we rest, how we prepare, how we gather our strength for the next phase of our journey. We sleep to recharge, we reflect to grow, we pause to understand. The universe, too, needs these pauses. They are not empty spaces, they are full of potential. The quiet between breaths is the foundation for what is to come. Without these moments of stillness, there would be no room for creation, no space for growth. Imagine the universe as a living, breathing entity. Its heart beat in a steady rhythm, expanding and contracting, creating and dissolving. But between each great exhale and inhale, there is a stillness, a moment of rest. This pause is not the end, it is a preparation. It is when the universe gathers itself, centers itself, and gets ready to breathe again. It is a time of reflection, a time to assimilate the energy of the previous cycle before it moves into the next. This pause is not just a cosmic moment. It is something we experience in our own lives, though often unnoticed. There are times when we find ourselves at a crossroads, when we are between two phases of life, when the world seems to hold its breath. It is in these pauses that we often find clarity, a new understanding of who we are and what we must do next. The universe, too, goes through these moments. And just as our lives are richer because of the pauses we take, the universe's grand story is deeper for the pauses between its great breaths. The idea that the universe might be holding its breath, waiting for the next great expansion, invites us to think about what happens in the stillness. We live in a world where action is celebrated, where movement is seen as progress. We often feel that to be stagnant is to be left behind. But what if the most important part of the cycle, the most essential moment in the universe's breath, is not the expansion, not the explosion of creation, but the stillness before it? What if this pause is where the true potential of the universe is stored? waiting for the perfect moment to unfold. In the silence before the inhale, the universe is not idle. It is not waiting in vain. It is preparing itself for the next phase of creation. There is wisdom in this pause, a wisdom that we are only beginning to understand. The universe may be waiting for a catalyst, a moment of alignment, before it bursts forth into the next phase. And in that moment of waiting, it is full of possibilities, full of untapped potential, just as we are when we pause to reflect, to gather strength for what comes next. And so the universe continues its cycle. But this pause, the silence before the next inhale, is vital. Without it, there would be no room for the next great act of creation. This is the space where the universe is born again, where the next breath is prepared. It is not just a pause in time. It is the pause that gives birth to everything that follows. As we stand at the edge of this cosmic rhythm, reflecting on the pause before the next inhale, we are led to a question that has been quietly echoing through the entire journey of this exploration. What role do we play in this grand cycle? We have followed the universe through its moments of expansion and contraction, seen the echoes of past breaths, and observed the stillness before the next great exhale. But where do we fit into all of this? Are we merely witnesses to this cosmic dance, or are we integral parts of it? The universe, as we have explored, breathes in a rhythm, expanding, contracting, creating, destroying. And within this grand cycle, we too experience similar rhythms. Our lives, though brief compared to the vastness of the cosmos, are shaped by moments of growth and stillness, by cycles of activity and rest. And just as the universe is not separate from its cycles, neither are we separate from the cosmic rhythm. We are participants, not just observers, in the ongoing breath of the universe. In this moment, as the universe seems to hold its breath, we are called to reflect on our place in this cycle. Every life, every being is a part of the greater whole. Just as the universe breathes through its stars, its galaxies, and its ever-expanding reach, we too breathe through our experiences, our actions, and our reflections. We are not small or insignificant, not isolated from the larger cosmos, but vital threads in the fabric of the universe. If the universe is breathing, what part of the breath are you? This is not just a rhetorical question. It is an invitation to step into a deeper understanding of your connection to the cosmos. You are not merely a passerby, standing at the edge of the universe, watching as it unfolds. You are a participant in its ongoing rhythm, its heartbeat, its breath. Every thought you have, every action you take, every moment of awareness is a ripple in the cosmic dance. This realization is profound. It suggests that our lives are not random accidents, not insignificant blips in the timeline of the cosmos. Instead, we are connected to something much larger, something eternal. Just as the universe learns and evolves through its cycles, we too learn and evolve through our moments of expansion and contraction. The cycles we experience are part of the same cosmic rhythm that governs the stars and galaxies. As we reflect on this, we begin to see that the pause, the silence before the inhale, is not just a cosmic phenomenon. It is a moment that mirrors our own experiences, Just as the universe pauses between breaths, we too experience moments of stillness, moments when we are between two phases of our lives. It is in these pauses that we often find the deepest insight, the greatest clarity. And just as the universe gathers its energy before the next inhale, we too gather strength and wisdom in the pauses of our own lives. In this grand cosmic rhythm, our awareness is a part of the breath of the universe. Every thought, every action, every moment of presence is a reflection of the larger cycle. The universe does not exist outside of us. It is within us, and we are within it. We are not merely separate beings watching from the sidelines. We are active participants in the ongoing story of the cosmos. And so, as the universe prepares for its next great breath, we are invited to reflect on our own role in this eternal cycle. What are we? Are we just fleeting moments in the vastness of time, or are we integral to the unfolding of the cosmic rhythm? The universe's breath is our breath. Its pause is our pause. Its exhale is our exhale. As the documentary draws to a close, we are left with a powerful realization. We are the universe, and the universe is us. Our place in this cosmic cycle is not accidental. We are vital to the ongoing rhythm of creation and destruction, just as each star, each galaxy, each cosmic breath is vital to the grand story. The pause before the next inhale is not just a moment of waiting. It is a moment of profound potential. And in this moment, we are invited to become more aware of our place in the cosmic dance, to see ourselves not as separate from the universe, but as an essential part of it. The journey of the universe is not a one-way path. It is a rhythm, a cycle that we are all a part of. And as the universe prepares for its next breath, we are called to reflect on our role in this eternal process. What part of the breath are you? The answer is yours to find as you embrace your place in the infinite dance of existence. If you want more calm journeys into space, time, and the hidden edges of reality, subscribe to The Calm Unknown.